Algebra 2, Chapter 4, Section 4, Functions and Change. So functions yield us to a new concept that we're going to discuss here of the rate of change, or in this case just the average rate of change, over an interval. So the average rate of change is defined over an interval from some number a to some other number b of the input. In other words, we just look at the numbers on the number line between a and b. We're going to look at this as our input, or our interval of interest for the average rate of change. And so we have the average rate of change is defined to be the change in the output divided by the change in the input. And we use this fancy Greek letter delta. It's a capital delta. It looks like a triangle. So this means delta. That's a Greek letter. So delta y over delta x, or the change in output over the change in input. And we could also think of this as delta f of x, because y is just another name for f of x. So the average rate of change is the change in the output over the change in the input. And we can write that out algebraically. And you see there's two different ways to write this, and they're the equivalent. We can either take the output from the end of the interval, subtract from the output at the beginning, and divide by the input minus the output, b minus a, or we can do it in reverse. We can use the output at a minus the output at b over a minus b. So let's use the definition that we just went over for the average rate of change to solve a problem. A ball that is thrown into the air has a height h of t as a function equals 90t minus 16t squared feet after t seconds. So first, what are the units of the measurement for the average rate of change of h? So remember, the average rate of change of h over an interval would be the change in the output over the change in the input. So we would have the units, if we think of the units, the output h is feet. It's the height in feet. And the input is in time, in seconds. So we have feet per second. What does the answer show about the interpretation of the rate of change in this case? Well, that means the rate of change is our velocity of the ball. The rate of change is the instantaneous velocity, if we could find the instantaneous rate of change. And the average rate of change is the average velocity over that time. Average rate of change is the average velocity. Part B. Find the average rate of change of h between these intervals. So start with part 1. The average rate of change would be the change in h, the output of h over the change in time, which is equal to h, and we can remember, we can pick either to start with. I'll start with the second this time. H of 2 minus h of 0 over 2 minus 0. Okay, so we can go over here on the side and find h of 2 and find h of 0. H of 2, putting in 2 for our function, we have 90 times 2 minus 16 times 2 squared. 90 times 2 is 180. 2 squared is 4. 4 times 16, we might want to use a calculator to find. So 4 times 16 is 64. Sorry. Minus 64. 180 minus 64 would be 120. Minus 4, or 116. So that's h of 2. H of 0, which would be the initial height, the height where we threw it at, is 0 because we have no constant term. 0 90 times 0 is 0. 16 times 0 is 0. Gives us 0. So this gives us 116 minus 0 over 2 minus 0, which is 116 over 2, which is, let's see, I think that's 58. Let's check it on the calculator to be sure. 116 over 2 should be 58, and it is. 58. So the answer to part 1 is 58 feet per second. 2. The average rate of change, again, is going to be change in the output over the change in the input. Why do I keep writing this? So I remember it, memorize it. If I write it each time I do the homework problem, then I will remember it very well. This time let's do first instead of the second one. So h of 1 minus h of 2 over 1 minus 2. Now we've already found h of 2. We can reuse that result, but we need to know what h of 1 is. So putting in 1, we get 90 times 1 minus 16 times 1 squared is still 1, which gives us 74. So we have h of 1 is 74. H of 2 was 116 over 1 minus 2. (74) minus 116. Grab our calculator. Negative 42. 1 minus 2 is negative 1. So the average rate of change will be 42 feet per second. And now for part 3. We have, again, the average rate of change is the average rate of change is the rate of the delta of the output, the change in the output over the change in the input, which is, we're going to do the last one first this time. Just have to be sure that we're consistent, that we put 4 here and 2 here and 4 minus 2 here, not 2 minus 4. We'll get the negative answer instead of the correct answer. So now we need to know what h of 4 is. H of 4 would be 90 times 4 minus 16 times 4 squared. So we have 90 times 4, 360. And we have 16 times 16, 256. So minus 256. Then we have to subtract 360 minus 256, so we get 104 as the output of h and an input of 4. So 104 minus h of 2 is 116 over 4 minus 2 gives us negative 12 over 2, which is negative 6, or negative 6 feet per second. C. Use the graph of h to interpret your answers to part B in terms of the ball's motion. So we have these 3 different intervals that we were looking at. So we have the interval from 0 to 2. That would be this interval from the input of 0 to the input of 2. It's looking at essentially the average rate of change over this part of the graph. Okay? And we can see that the average velocity is going to be positive from 0 to 2. So the graph shows a positive rate from 0 to 2. which is the same as our answer. Right? If we flip back, our answer was, for part 1, 58. Now if we look at the rate from 1 to 2, that's an input of 1 to an input of 2, from here to here, we still have an upward motion, a positive velocity. So we still have a positive rate from 1 to 2. What we expect is from 2 to 4 for it to be negative, going down over that interval. So from 2 to 4, if we look at the graph, we have an output here at 2, an output here at 4, and over the whole interval, we've gone down. So over the interval from 2 to 4, the velocity is negative. The ball's gone down.